So guys, in this video I was going to make a clarification on what I did in the past two videos. So if you remember, we went over the stack in the last two videos. And in the second one, I basically only used the stack. And what I did in the beginning to initialize the display was, I basically allocated the opcode to input to the display to the stack, and then I put the cursor position opcode to the stack, the initializing it as a 5x7 pixels display on the stack, and then I pushed the clear display on the stack as well. And then I basically went through a loop and popped these values or retrieved them in a reverse order. So first we cleared the display, set it up as 5x7, set the cursor position and set it to input mode. So basically after that, our stack pointer will reset back to 0 on FF, because it started here and it went down like this when we were pushing, and then when we popped it went back to 0 on FF. And then after that we didn't have to set our stack pointer to 0 on FF again because it's already where it's at. And then we basically pushed all of these characters for hello world like this, and you're like, why is it in reverse? The same reason these were in reverse, because when we pull from the stack, we're pulling the H, and then the stack pointer goes here, we pull the E, stack pointer goes here, pull the L, stack pointer goes here, pull the L, stack pointer goes here, and etc. And then I also want to tell you guys that the start address of the ROM that I'm using, I basically over here set it as 00, and then the final address I set it as 0x8000. So that it's in little endian. So the ending address is 8000 because we did 7FFD as 80 and then 7FFC as 00. So the beginning is 0000 and then the ending is 8000, and the reason for that is it's a little endian. As you can see, even like, for example, this address is in little endian, it's in 6000. And then to write it out to the rom.bin file, we basically just did with open rom.to wb, and as output file.write to the rom. And basically I was using this programmer, the TL8662 Plus, and to remove the ICs and put them into the TL866 Plus, I like to use tweezers like these. I like to put the tweezers like this, grip the ROM, bend it upwards, remove it, put it in, and you want to put it in like this, as it shows, and then put this lever down, and then you could plug it into your USB port and program it. And you might be wondering why, when you open the text editor in the programmer software, the code has all these EAs. What is this? This is our original bytecode that we wrote, the machine code for Hello World and the stack, and then all these EAs everywhere. Well, it's padded with these EAs because on this line of my code, I did ROM, so code equals byte array. So then we made another byte array called ROM equals code plus byte array 0xEA, which is the opcode for 6502 for no op, so it does nothing for, I think, 2 clock cycles. And then multiply that by the amount of addresses in the memory minus the length of our code byte array. So basically everything that isn't in here will be padded with EAs, so the computer does nothing for those clock cycles. And generally, you could put a jump to 8000 and it'll go back to the beginning. So I hope it wasn't confusing. So 8000 is where we basically would jump to go to the beginning of the code. And then usually you want to skip these, so you jump 8000, 8001, 8002, 3, 4, 5, 6, 7, 8, 9. So you could jump to 8008 if you wanted to just loop through this hello world code constantly. So yeah, there's a few clarifications